We're back with another talk that it's really interesting from my perspective because it's about something old and something new. Um, we all know that we like greenfield projects because endless possibilities. But this also means that sometimes, so you can try whatever technology you want without any big issue. What if you want to try a technology, with a new technology, with something old, with something legacy? So usually those two things don't work necessarily nicely together. So today we have Greg to walk us around.
Hey.
Hi, Greg. Nice to see you. To walk us on about how to get something as cool as GraphQL to work as nicely as possible with legacy code. And I really like the title of the
It's one of my favorite words
because,
in the English language. Fuzzy.
I think yeah. There is so much meaning behind it. It's perfect to define this fluffy but also weird
But also adorable
thing that is
and nice to
happening.
touch, right?
How are you?
Yeah.
True, true. What was the name of those? Was it trebles in Star Trek? Do you
tribbles.
remember
Tribbles
those
or trebles.
fuzzy, fluffy
Yeah.
animal? Trebles, right? I mean, they're super cute.
Exactly.
Also problematic sometimes.
They tend to go out of control.
um, I want to talk to you sometime about your Arduino-powered cat feeder because it's something really interesting. So Greg is a senior software engineer at TopTal, and he has been around software engineering for quite some time for his personal interests, but also for work.
Yeah, exactly.
The past
Actually
10
over
years,
12 right now.
Doing Ruby. Nice, nice. Getting to the 15, then we need to celebrate
No
again.
problem.
Milestones. Greg is going to have a pre-recorded talk, so memorize your questions, share them in the chat, and we will see each other afterwards for the Q&A. See you later.
Hello everyone, I'm Greg, and today I'm going to talk to you about growing your GraphQL API and the problems that you might encounter. So, I'm a backend engineer at TopTal. We have a pretty big organization using only GraphQL for a few years now, and I hope I'll be able to help you with your possible issues. So, I'm very disappointed that we're not in Verona right now. I was hoping to see you guys in person a few months back. Well, all is not lost. Let's hope that sometimes we can meet, maybe next year. On the plus side, you will be able to actually get the benefit of a few months of additional knowledge, both from me and from TopTal as an organization, which I do. Most of the recommendations here I will get from our official internal docs. So, let's start with a bit of history. 4 years ago, I did my first talk on GraphQL. It was about how a small group of backend developers had to support a large team of front-end developers, and we were struggling with REST. So we switched to GraphQL just as an experiment, and it turned out that developing GraphQL APIs is better for both us as backend developers and the consumers because they have a more flexible API and they don't need us for each change. That was kind of important at the time because REST was the dominant paradigm at that time. definitely in the Ruby world. So I urge my listeners to try out GraphQL and see how it goes. And at the end of that presentation, I also said that probably, in my view, like as you scale your operations for the APIs, this will definitely benefit you. Like using GraphQL will benefit you compared to REST. And 4 years later, little did I know that that would definitely happen in TopTal. So we now have 9 schemas, and we started at 1, we now have 9. We basically, this is our standard. Everyone that wants to use something inside the organization has to use GraphQL as an API. We do a lot of modern front-end apps that use that GraphQL. So pretty much everyone inside the organization has to have some familiarity with it, if not directly working on it. And what's interesting in this case is that we have partially moved our services to partially moved our schemas to different services. So that's an additional kind of interesting thing. That leads to all of this scaling of the API leads to a whole different class of issues that we had in the beginning. So what I want to get for you in this talk is I want to introduce you to the problems we had while scaling the API. I want to suggest some possible solutions and give you recommendations around those. But I will definitely not be able to go to everything in depth, so treat this as a kind of reference for later on. Finally, what I would like to say to those of you who already have that little voice in their head saying, well, this is probably not for me, we don't have that big of an API, we have some plans to scale it, but not to those levels, so this presentation is not for me. Well, first of all, it's even if you have a small API, most of this will still benefit you. If you have a small API, it's still easy to make it ugly and inconsistent. It's just a lot easier to do that when you have a larger organization and you're working within different teams that don't always communicate directly. So on the other hand, remember that this didn't happen to us like as planned. We didn't decide that everyone from the company will use GraphQL. All of those teams, we moved gradually, one kind of team, product at a time, and we did that gradually. So this wasn't like a whole company pushed GraphQL, but now we'll set standards, now we'll be all on the same page and do things the same way. No, it happened gradually, and that kind of complexity can sneak up on you and catch you unawares. So it's good to be kind of cognizant of the fact that you will probably encounter these problems at some point, and the earlier you act, the better, and the easier this transition will be. So if you don't do that, you will have the most obvious problem is that you will have reusability on the front-end side. You will not be able to expect particular patterns to come out of the API, which is just kind of a problem for all your consumers, but especially for your front-end engineers. And you will have different standards, and you will have an ugly API. No one wants to work with ugly things. If you have a public-facing API, for example, you might face a lot of criticism. If you have an internal API, you will have developers that are just unhappy to work with that API. And that's not just aesthetics. That's concrete man hours lost for each part that's not clear enough. Your API is like code. No one wants to work in ugly code, but not because of aesthetics. We don't want to work in ugly code because we have to spend additional mental resources to understand what's going on in that ugly code base. So this is a concrete kind of man hours and morale loss problem, not kind of static thing. So I guess let's start. Let's start with something simple, basic standardization options. As you know, any standard is better than lack of standard. So write those out somewhere, get them out of the way. You have a starter pack here, and just enforce them inside your organization. There's not much to say about that. A step up is enum usage. Enums are fun. Enums are predictable, and you should use them wherever possible, but you should not overdo it. Don't use them in sets that can change and that can add, for example, have additional values. Finally, as a front-end engineer, you should probably not count on the introspection on the enum to be your guiding light. If for example, an value is added to an enum, does your code handle that? Or does it list all the enums and doesn't expect that some of those sets will change? That's actually a kind of problem, and it's not obvious how you can deal with it. So this will be something that you have to figure out on your own. Another problem is, how do you handle many-to-many relationships? You can handle it via lists. So this is an example of a simple list of credit cards on the client. It's simple and it's clear, and it has no paging support, and you have a direct representation of a one-to-many relationship. This is something else entirely. It's a connection. Here we have a list of invoices, or rather a connection of invoices. As you can see, a connection is way more complex, but it also covers you in most of the cases. A connection is a standard developed by Facebook in order to work with the Relay library, and it's designed to help you with cursor pagination explicitly. So you will have everything you need here in order to be kind of future-proof. If you would implement all of your many-to-many relationships as a connection, you would be pretty much safe for the rest of your life, because nothing more can happen to your kind of data model that this connection won't be able to handle. However, it's as I mentioned, it implements the cursor paging and paging info. It has a complex schema and queries. That's the only downside. So if you want to create something more simple, I would suggest that you actually try to create your own pattern. This is the same pattern as in the connection, even with some values added to it, but you have less levels of indirection. You don't have the edges structure, you only have the nodes for the invoices, which lets you get to the data that you usually want to have as fast as possible. And you can always add some metadata here if you want. You can abstract this into a specific type for use inside your API. So it's up to you. The only downside is that this isn't a standard. You will create your own, but it's not a big issue. So our recommendations are that you use lists only when paging is not probable. So basically, if you have a client, it's quite improbable that the client will have more than, let's say, 10 credit cards. So it's perfectly reasonable not to expect paging in that instance. Otherwise, figure out and implement a custom pattern. It should be future-proof, and it should be as simple as possible. You saw that pattern that we suggested. If you want to, you can adapt it. Ignore connections unless you're working directly with Relay. A lot of libraries don't treat connections as they used to, because it seems to be a standard that's on its way out. Let's tackle the problem of sorting, filtering, and paging. It's not really a big problem. It's more of a standards issue. once you write them, it's pretty easy to enforce. And the rules of thumb for all of those is that you keep them separate from each other. What do I mean by that? Well, let's take a look at this. We have the filter, we have the pagination, and we have the order as separate parameters on the field. And that's pretty simple, right? You would think that this would be like self-explanatory and you would implement it every time the same way. However, let me provide you with a kind of scenario here. So let's say you want to implement a list of clients. You do that. You don't have any parameters yet. You just want to list all the clients and that's it. Then the list of clients grows and you have a feature to implement to allow filtering of only the clients that are set as enterprise. So you introduce a filter as a field parameter. Makes sense, right? It's a simple implementation of what you directly need at this moment. However, in a few commits, you will have something like this. You will introduce additional parameters, then the list will turn out to be even too long for that, so you will need pagination, you will have sorting requirements, and everything will be jumbled up. So this is a kind of representation of one of the primary issues with ugly code and bad programming. These are mixed levels of abstraction, right? If you have is enterprise, that should be tucked away inside the filter structure, and you have it at the same level as you have the order. So these are mixed levels of abstraction, and it's hard to read and it's hard to get your head around what in that field exactly does what. It's not impossible, but it's definitely going to be a problem as you create more of those fields. So those were the pretty simple things that you can handle even in small APIs. What happens when you grow your APIs a bit? When you grow your APIs a bit, you'll probably find that you want to create different schemas. That's because you want to separate concerns, and schemas are actually code. Your API is your code. So you don't want to have one big schema that's jumbled up or divided artificially. You want to have schemas that provide value for the apps that you're building. You can make, therefore, a separation of concerns, and you can also make a separation of representation of the underlying data for your domain models. Let's have an example. You create an app for your staff. That staff app lists clients. And it has an ID, the client has an ID, a name, some other info probably, and has some sensitive data. That's fine. We actually need to expose that sensitive data to our staff. And we expose those clients and we expose the stats, and it's fine. And then a few months later, we want to create a similar app for the talent. For example, in TopTal, talent is our freelancers and clients are the people that they work for. So the clients are, the talent probably should not have sensitive information about the client. However, when you work on the talent app, you don't really see that directly. You don't see, you don't know what exactly the talent should have access to. And you see that there's already a client type. So reusability is good, right? So let's reuse the client type. And so we create a talent schema with the client type. Simple enough, right? But the problem is that now we have exposed the sensitive data to the talent. That's because it's very easy to reuse types between schemas, and that's also why it's easy to share too much data between the schemas. And it's also hard to check where that type is used. What I mean by that, In this case, you might say that, well, obviously the error was on the talent app developer. He should have seen the client type, and he should have seen that he's exposing sensitive data on the client type and not make that decision to reuse the type. Well, that's fair enough, but there's more subtle ways to do this that are harder to find, harder to figure out. So let's say that we created the staff app, and at roughly the same point, but after creating the client type, we create a talent app. Let's say that the initial version of the client type did not have the sensitive data field. So where the developer created the talent app, he did not expose the sensitive data directly. And then a developer from the staff app comes back and gets a requirement for a feature that says, okay, we want to show, our staff wants to have info on the sensitive client data. So can you add that to the client view? So he exposes, the first step is to expose the sensitive data to the staff app. The problem is that this type is already used by 2 apps, and he also exposed it on the talent app. And it's not, you might say that, well, he should have checked every schema that uses this type, but it's not that simple, and sometimes there's technical issues why this might be a problem, especially if you have a big API. This will be harder than it seems, and it's just easier to not reuse those types between schemas. Types are very thin layers of representation around your business data. You should treat them like decorators, and thus it's just usually a couple of lines, a couple of minutes to create new types and integrate them inside the API. If you're not creating, if it's not easy for you to create types, you're probably doing something wrong with them. For example, if you have business logic in the types using complex resolvers, that's probably a cold smell. You don't want to have any business logic inside types. The types should be very thin representation of your data. You should have that business logic on a different abstraction level than the type. Finally, there's a caveat to this recommendation. You should reuse scalar types like datetime, let's say currency, order constructs, paging constructs, and so on. That gives you a kind of reusability, but it also gives you a standard across your API, and it makes the API kind of the same on all levels if you decide to reuse those. So scalar types are fine. Just don't reuse your business logic and data. Now, we come to the point where you want to distribute your GraphQL API. Why would you want to do that? So if you don't have to do that you probably shouldn't. It goes with a set of problems on its own. Not all of them code, but also infrastructure. So if you don't have to separate your APIs, it's fine if you don't, but at some point you might have to, or feel the pain enough of a huge API that you will want to separate them into different things. Usually that gives you some flexibility because you can separate parts of the API into separate teams that can work on them faster. Those are smaller projects that require less cooperation from different teams. They're separated inside team, and that team handles it, and that makes it faster to develop. But it also makes the API harder to use, because if you have separate services, that gives you a few APIs. So let's say a front-end component needs invoices. It hits the core API for the invoices, but it also needs additional data regarding to billing and regarding the history of those invoices. So it also hits the billing API and the history API. and it jumbles up that information in the end and has enriched information. So there are several problems here. There's several queries needed, first of all, to complete that enrichment and have a full set of information. Another problem is that the consumer has knowledge about where the information about a particular invoice lies and which information is on which service. So in this case, it needed to know about 3 services and schemas to hit. That's a problem, mostly because you don't want the consumer to have that knowledge. That's not on the the consumer doesn't have to know that. He shouldn't be required to have that knowledge. So it would be good if we could put it out somewhere. And let's also think about what we want. What would happen if we, for example, want to divide one of the APIs further? So let's say we want to divide the history API into sent emails and performed actions on invoices. In order to do that, you will have to go back to each component that already uses the history API, all the consumers that use the history API, and tell them what has changed in that API, and that they need to change how they query it to now use 2 different services. The alternative is the Gradual Pattern. You have a single graph that combines all the data in one place. So this gets rid of all the problems that I told you. So this is a pretty kind of no-brainer that you should use the gateway pattern right away, even if you don't have separate services, even if you only have one service that uses several schemas, you want to use this gateway pattern because it allows you to have a single graph, and all that knowledge is how those schemas interact is hidden inside the GraphQL gateway, not the front-end consumers. So we decided that we want to have the gateway. There's one more decision we need to make. We want to decide whether we want schema stitching, which is basically merging 2 top-level query objects together to produce a new one that has all the fields from all the query, and this produces a usable API. The problem is that it doesn't allow for extending types, so it's a very primitive method. What's better than that is what's called federation, and you can use it with Apollo server, and it uses slightly different pattern. As you can see here on the left, there's just a single type within the schema. For clarity's sake, in the middle we have a product, let's say schema, that defines a new type, but also extends the type from a different schema to use that new type. So we see here a separation of concerns, that this product schema is only concerned with product and how that product gets used by other types. So it actually does a pretty good job of adding functionality to a different type. And in the right schema, you can see a more complex example where it adds a type and extends 2 types defined in the previous schemas and enriches them with its own flavor of information. This is the best possible solution right now, so we recommend that you use Apollo Federation. Remember that we suggest that you do it from the beginning, not only when you have separate services, but only even when you have just different schemas running on the same service. So take care to divide your services by concerns, by the teams that work on them. It's up to you how you do that, but just don't randomly divide schemas into, for example, how the data is structured. And beware the usual plague of Rails, which is God objects, which is the tendency for kind of central data objects to pull in functionality from different areas because they're related to it somehow. That's why we in Rails often have a user object that's several thousand lines long, because it tends to pull in functionality from other areas of concern to itself. And that's it for me for today. There's a lot of things missing in this presentation, but we only have 30 minutes. So I would like to kind of suggest to you that these problems are the ones that also exist, and you can find information on them on the net. And if you run into that problem, maybe you will remember this presentation and say, oh, that's something that someone talked about somewhere. Maybe I should take a look at that again. So here the interesting things are errors, both top level and on a user schema, which is basically a division of out of schema and in schema errors. And read up on that. You want to have a set of validation errors. You want to have it standardized so that you can handle it the same way in your consumers. You want to figure out how batching works in order to avoid N+1 problems. Hopefully you will have that figured out at this point, but there's some additional problems with that, especially if you're using federation or schema stitching. And Apollo Federation is a whole topic in and of itself. You can find great presentations on YouTube that introduce you to Apollo Federation and tell you how it works. There's also the whole area of service instrumentation if you have more than one service. And there's probably a lot more that we can talk about, but not today. So with that, I will leave it open to the questions.
Hi, Greg. Welcome back.
Hey.
This has been, we really did a good job at picking the talk this year. This was also extremely interesting. And I really enjoyed the clarity of your explanation. It was amazingly done. Thank you so much. While we wait for potentially other questions in the chat, I do have a question myself. And because I was having this conversation some days ago on Twitter, when I was reading, I never use GraphQL in production. Let's put it this way. And a friend of mine on Twitter was saying that he sees more problems than advantages in using GraphQL. So I was wondering, given that you have so much experience in using it, are there some cases in which you wouldn't recommend to use GraphQL?
It kind of depends. The GraphQL really lends itself well to product-based APIs, let's say. So if you have kind of a specific kind of graph of data that you want to expose to people, be it internally or externally, that's probably a very good idea to do it. It doesn't lend itself, I guess, well to things, APIs that are mostly that mostly use them to write something, for example. So let's say some kind of image processing or similar kind of. The more product-oriented and data-oriented your API is, then probably GraphQL is the best option for you. However, you can also do those things in GraphQL. And frankly, I haven't, for the last few years, I haven't used REST. So, so I personally, I find GraphQL a better case in pretty much all all that you can do. So I was trying to find some reasons just now off the top of my head, but there might be some very good edge cases. But for your standard kind of application that has a back end and a front end, I think it's a very good choice.
Thank you. Yeah, we have had this conversation a few times in my company, if we should stick with REST and or if we should go more into GraphQL, having even not specifically talking about the technology itself, but should we abstract the complexity of our APIs with all the versioning and things like that into an API gateway? And what you were presenting in one of the last slides was going in that direction. So
that's kind of what killed us. Like I mentioned the talk 4 years ago, so that was pretty much why we tried GraphQL, because REST was just killing us. We had like 9 front-end developers and 2 back-end developers, and most of the time for the back-end developers was spent just minorly tweaking endpoints to add fields, sometimes to remove fields if they were no longer needed, and to implement filtering and so on. So it was pretty much because of the limitations on some Ruby gems for REST at that time as well. We had problems like we spent most of our time just reacting to what the front-end developers were doing instead of building what they could actually access and leave the choice up to them. So that's the main point of GraphQL, that you build a data graph and then you leave it up to the person that uses it to only pick what she needs from that data graph.
Makes perfect sense. Very often in my experience, you end up exposing more information than it's needed, because to avoid this kind of like nitpicking, so that the client can then on its own terms decide what to pick in which version. But this usually then ends up with endpoints with tons of data into it that then affects performance and so on and so forth. So
yes, that was even like we've had a relatively small API, and that was already an issue. So we decided that if it goes this way, we want to make this API at least five times as big as it was. So this will be totally an issue going forward. So we just bit the bullet, like scrapped a month of code and started working on a new API just to check if this will work better for us. It's also interesting in REST you have weird endpoints like dashboard, and sometimes you have dashboard staff, dashboard client, dashboard whatever, and that doesn't happen in GraphQL, because the front-end users for let's say the staff app just takes the data that they already have in the whole graph and use that data to build the pieces relevant for the staff. And if they want a client dashboard, they just take a different set of data, but from the same API. So it does really good in these kinds of use cases.
Thank you. There is one question from Tiago that was asking, are your GraphQL implementations usually in Ruby or JavaScript? The question stems from the fact that he heard that the support on JavaScript is much better for flexibility and performance and other things among them.
We use Ruby inside our organization, so all of our APIs are in Ruby at this point. But that's mostly just because we use Ruby as an organization. We have hundreds of Rubyists on our team, so we don't want to force them into a language they're not comfortable with. And it's not. We haven't hit upon a threshold that we would need more performance, for example, for a given API. So we use Ruby on the backend. The only parts for in JavaScript that we use is the aforementioned Apollo federation.
Mm-hmm.
But I guess if you that's something I didn't mention in the presentation. If you're federating different services together, you could, for example, if you have a schema that requires a lot of performance, you could write that in a different language than Ruby if you want to, and seamlessly with Apollo Federation stitch that together to actually be in the same graph. The consumer doesn't even know that you have
Exactly.
a part of the API written in Go or something. So
Yeah, makes perfect sense.
That's quite
It's
an
completely
interesting
visible.
concept.
Yeah.
Yeah, it's kind of microservices for your API, but
Yes. Yes.
but no one sees that it's actually microservices as it should be.
Rightfully so. We have, I think, two more questions. One is from Janko asking if Active Record somehow knew how to automatically eager load associations. Would you still need special GraphQL batching logic?
Let me think about that. If it knew, probably you would need definitely a lot less of it if Active Record knew, but it's usually not. There's a trade-off, right? Eager loading does a trade-off between memory and speed. So Active Records would not only have to know at which point to eager load it, but also to know which at which situations, unless you told it to batch load something. And also to that directly to the question, no, it wouldn't help at that point, because if you're doing a GraphQL, you can't really know ahead of time what you're going to be working with, right? Because your consumer can dynamically create a query. So let's say we have a product, or we have a client and we have a product related to that client. It doesn't know whether we only will know how to fetch the client. The consumer will want to fetch only the clients or the products as well. If we want to fetch the products, the GraphQL batching is also there. For example, that if we took let's say 10 products, and then we want to load the same products but in a different part of the query tree. So we also want to load those products for the cart. The batching is there to make sure that we're not loading those products twice, even because they're the same ones. So that's kind of over Active Record. That's a level of caching that's over the whole query, not the particular kind of Active Record models and relations that you're working with currently. So you can have products related to have different associations between product and something else. And that GraphQL batching layer will handle that, even though it doesn't know about those associations. It just knows that we're loading the same products within different areas of the query tree. So it doesn't. So it handles that, and you won't have to load them twice.
Yeah. So not really the use case we are trying to address. One last question. Does GraphQL support HTTP level caching? Are they asking?
I've seen people try to do it, but that's, I think that's not up to spec, because GraphQL requires you, the spec requires you to send a post request with each query. So that's inherently not really cacheable. I know that, for example, the Ruby gem has something called stored queries or something like that. So it handles caching on a kind of query level, but I haven't used that a lot. So the answer to the question is no. Basically, it doesn't use HTTP caching because it can't, because you send a post request, and that's inherently something browsers don't handle as something cacheable, basically.
Yeah, makes sense. Thank you. So there are two more questions, but they're pretty big. So for the sake of time, I'll let you answer them in the chat directly to the people. Thank you so much for your time and for your availability.
Thank you, Monica. Thanks,
Bye.
everyone. See ya.
See you later. Bye.
you.